Guys, I'm going to do the answer key for practice exam 2 for unit K. All right, so the very first problem, this is from K-2, we have to evaluate this integral. And in order to do that, you've got to rewrite this like so. So you go 2x cubed, and now this polynomial 2x cubed is missing some other terms. It's missing the x squared term, the x term, and the constant term. So you have to go 2x cubed, 0x squared, 0x, and 0. And then you go like this, x plus 8. Okay, so 8, or x times what makes this? 2x squared. And then so this is 2x cubed plus. And then you subtract, so this is negative 16x squared. Bring down the next one. X times what makes this? Minus 16x squared. And then that's minus 128x. And then I change those signs. 128x and down to 0. All right, x times what makes that? Plus 1024. And then you've got to negate those. So you end up with negative 1024 as the remainder, and then over that. Okay, so the inside here is equivalent to this, and I'm going to split the integral up. Plus, or actually, you know what? Let me just pull out the 1024 now. And I'm doing a fraction bar because I'm going to use f prime over f on this next integral. So I might have to multiply the numerator by something, and whatever I multiply the numerator by, I've got to divide by outside. So that's why I'm just leaving some space here. And then inside we've got 1 over x plus 8. Okay, now these antiderivatives are going to be super simple. But this one, we need to use f prime over f. Okay, so off to the side, I'll just say that f is x plus 8. So f prime is 1. So guys, we needed the top to be 1, and it already is, yeah. So then you could just divide by 1 outside if you want. Okay, so now taking the antiderivatives of these is 2/3 x cubed minus 8x squared plus 128x minus 1024 natural log absolute value of x plus 8 plus c. Always at the end of plus c for an indefinite integral. Okay. Now guys, if it wasn't clear to you how I got from here to here, we've actually been doing that for a really long time, and it should be clear at this point. If it is not, you've got to come talk to me or talk to a friend so they can explain it to you, because it comes up a lot. And if at this point you still don't understand it, you've got to take action. Okay, now down here, find the area bounded by the curves below without using Math 9. Okay, so we're going to need to use the fundamental theorem. So without using Math 9 means use fundamental theorem of calculus. Okay, that's also called the FTC. That's when you bring down the brackets, put the antiderivative inside, etc. Okay, so this one here, guys, if I look at these functions the way that they're labeled, x is already solved for. So that means that these functions are each represented in terms of y. If x is solved for, that means in terms of y. And when things are in terms of y, we're usually using right minus left. Okay, you could actually, in order to get the area between these curves, you could also do top minus bottom, but that would involve us needing to solve for y so that things would be in terms of x. So I'll just do right minus left here. Okay, so the formula is that the area between these two curves is the integral from y equals lowest y value is 0, highest y value is 1. And on the inside, we're going to do right minus left dy. The integral from 0 to 1. The right function is radical y minus y squared dy. All right, guys. Now, you've got to recognize here that radical y is y to the 1/2. Okay. So now I'm doing my brackets. 1, 0. Antiderivative goes inside. Antiderivative of this, 1/2 plus 2/2 is 3/2. So it's going to be y to the 3/2, but then here I have to do, this is a 1, so 1 divided by 3/2 is 2/3 after keep, change, flip. And then that's minus 1/3 y to the 3rd. Okay, now I'm going to plug 1 in, so I get 2/3 minus 1/3 minus, and now I'm going to plug 0 in, and these both become zeros. So 2/3 minus 1/3 is 1/3. Okay, so there is that answer. And if you look at the answer keys, guys, in our, actually, why didn't I just tell you now? Yeah, so the points are on the answer key. But there's going to be, this is 4 points here. That is another 4 points there. So this page is going to be 8 points. Okay. The shaded region shown below is bounded by the functions f of x, which is that, and g of x, which is that. The y-axis and the line x equals 2. So it's bounded by all those things. Find the area of the shaded region using a calculator rounding to the nearest thousandth. So we're going to need to use Math 9. All right, so let me get out this thing here. Okay. So first let me label my graphs, okay? Here we got these two graphs, two functions. They have graphs. This one is a line. So this line here, that's what g of x is. So g of x, 0.75x plus 1. And then this is a parabola. Okay, so that's going to be that one. So f of x, 4. Okay. Now, so this shaded region, guys, is really composed of like these two shaded regions. And we're going to want to use top minus bottom. Okay. So on this section, top minus bottom, the top is f, the bottom is g. But then past this intersection point here, it changes. This time the top is g and the bottom is f. So we're going to need two integrals. Okay, and to understand where the endpoints are, we've got to find this intersection point here. This x value here is clearly 0. This x value here is clearly 2, but this one we don't know. And all I need is the x value, guys, because I'm doing top minus bottom, which means everything in terms of x. So, yeah. Guys, to save time, I'm just going to tell you, or actually, why don't I do this? I'll do it. Okay, might as well. All right, fast forward through this part, guys, if you know, if you already understand how to get this and store it, because we're going to need to store it. Okay, so let me graph f of x, negative x squared plus 4, 0.75 x plus 1. And I'm graphing it. Okay, so I need to know what this intersection point is right here. So we do this. Okay, so there it is. Okay, I'm gonna store it. Let me first just like write it here. So x equals 1.3971 dot dot dot. Okay, so I'm not even rounding, I'm just, saying dot dot dot. And then I'm going to store this as A. All right, so I'll just indicate there that I'm storing that as A. So I go back to my home screen. I hit X. That gives me the same X value that my intersect feature found. And then I store. Okay, store is this button right here. And then I choose A. Okay, so now I can use that in my calculator. Okay, now I'm ready to write the integral. There's going to be two of them. So there's going to be the integral from the x value 0 all the way up to the x value A. Okay, and then inside here I need to do top minus bottom. So the top function is f of x squared plus 4 minus the bottom function is this one, dx plus the integral. So the next region, the first x value, the leftmost x value is a, and the rightmost x value is 2. So that's going from a to 2, right? And then they're just switching 0.75 x plus 1 minus negative x squared plus 4 dx. Okay. And then guys, you could simplify a little bit, like if you want to, like on the insides, or you could just go directly to Math 9, okay, which I did. So I go Math 9, and then I already have A stored, so I can go from 0 to A. And let me just save time here, guys. Dx. Okay, that now in here, you're gonna type this, like with parentheses and everything. And then you're going to go plus Math 9 again, and then you're going to go from A to 2, right? And you'll make sure you have a dx at the end. And then in here, where that is, you're going to type this inside with the parentheses exactly as it appears, okay? And then once you hit enter, I'm just saving time because I already did this, 3.267. Okay, so that should be that. You should do that, guys. Okay, you should type it in, make sure that you get that same number, and yeah. Okay, now this next one. All right, so that was worth 4 points. All right, so that was another 4-pointer. The next one is also a 4-pointer. Let the region R be the area enclosed by the function f, the horizontal line y equals 3, and the y-axis. If the region R is the base of a solid such that each cross-section perpendicular to the x-axis is a square, find the volume of the solid. You may use a calculator and round to the nearest thousandth. Okay, so guys, if these, oh yeah, and so we don't really, all these intersection points are like super clear. Oh no, I think this goes like all the way to 0. Yeah, so 0 is actually where that, because it goes like an at, yeah. All right, and then, yeah, so there's those intersection points. So perpendicular to the x-axis means that these slices, and their shapes are squares, are going to be slicing through like this. Okay, and so when you go to find the area of one of these square slices, there's infinitely many of them, you're going to be doing top minus bottom, and that's going to give you the length of the base of the square. Okay. All right, so the way that you do these volume ones, guys, is, okay, so we have the integral from 0 to 1 leftmost x0, rightmost x1 for the region. And then inside of the integral, you're going to find the area of just one cross-section. Each of these infinitely many cross-sections are slices, I should say. A cross-section is like a slice, are squares. So off to the side, I'll do a little aside. So A of x. A of x is the area of a square. The area of a square is base squared. Okay. And then, but the question is, guys, how do you find the base? The base is top minus bottom. Okay. Then once you have that figured out, you just got to put in the top function and the bottom function. This top function here, that falls on the line y equals 3. And then this bottom function here, that is this one, 3x to the 1/3. Okay, so guys, this is A of x. This is what's going in here. So this is from 0 to 1, and then 3 minus 3x to the 1/3 squared dx. Okay? And then you do math 9 in your calculator, okay, because it said use a calculator, and you end up with 0.899 or 0.900. Guys, the AP people, they want 3 decimal places, okay, at least 3 decimal places, but it doesn't matter to them whether you round up or down. The answer your calculator gives you is 0.899999999, okay? So that is either going to round up, that is either going to like round down basically to this, you just, cut it off and don't do anything with the 9s, or you can round up to that, okay? So I don't know, I guess I'll use this one, and there's that. Okay, so that is also a 4-point problem. Moving on. All right, how many more? Okay. Got a few more. Okay. Let the region R enclosed by the function, same as before, the horizontal line y equals 6 and the y-axis. Find the volume of the solid generated when the region R is revolved about the line y equals 6. You may use a calculator. Okay. So guys, if you watch the videos, you will have seen that the way that I usually do this, okay, so first I identify the axis of revolution. All right, so this line here, this line y equals 6, that is the axis of revolution. So I'm going to be taking this region and spinning it around and around and around and around and around. And it's going to create like a solid shape, okay, almost like a cone, but not quite, because of like this dip. So something that could help is that you take this region and reflect it over the axis of rotation, okay? And when I do that, I end up kind of with, it's not going to be like perfect, but something like this, I guess. That looks awful. Yeah, something kind of like this, okay? And then after I do that, I draw a cross section. I draw a slice. Now, since this is going around and around and around, the slices are either going to be discs or washers, okay? Discs are just like a circle. Washers look more like a donut. Okay, so I'm going to go like this. So first I find a radius. All right, so this is going to be the radius of one cross section. And then, when you're revolving around, it kind of makes like this type of shape, and you just imagine like infinitely, like many of them. All right, now, in order to find the area of this cross section, of this slice here, we're going to have to use top minus bottom to get the radius. Okay, so guys, very similar to the last one. Whenever you have volume, you're doing the integral in this case from 0 up to 8 for the x values, and then the area of a cross section. Okay, now I'll do a little aside. Okay, so the area of a cross section is going to be pi r squared, because that's a circle. So this is going to be pi r squared. Now for r, I have to do top minus bottom. This top minus this bottom. So this is pi. The top is 6, the bottom is that. So this is going in for a of x. But the thing is, guys, you could pull the pi out front because that's just a constant multiple. You can never, ever pull variables out front, but you can pull constant multiples out front. Okay, you plug that into your calculator, you don't forget math 9, and you end up with 90.478. And guys, you should do that. You should plug it in your calculator and see if you get it right. That is 4 points. All right, guys, we got 3 more. Okay, consider the differential equation right there. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Okay, so guys, you look at these 12 points. There's these 4 that all have an x of -1. There's these 4 that all have an x of 0. There's these 4 that all have an x of 1. So that's how I'm going to arrange it when I do my slope table. Okay. 1, 2, 3, 4, 5, 6, 7, 8, and then x, y, dy, x, 1, 2, 3, 4. Okay, so first I'm going to write down -1 4 times because I'm going to have 4 points with an x value of -1. Then I'm going to write down 0 4 times in the x column. Then I'm going to write down 1 4 times in the x column. And now the y's keep going. This y is 0, this y is 1, this y is 2, this y is 3. So the y's that go with the x's keep going 0, 1, 2, 3. So 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Okay, now I've got to plug these x's and y's into dy dx. Okay, so the x is going here, the y is going there. Now guys, for this x, so dy dx is x squared times y minus 1. So if I'm squaring this x every single time, I'm just getting a 1, 1, 1, 1. All right, so that's the x squared. The x squared part is just going to be 1 every time. Now, next to that, I've got to put the y minus 1. So in these parentheses, I'm just going to take this y and subtract 1. So that's -1. That's 0. That's 1. That's 2. All right, I'm just trying to suggest like how you could do this fast. -1, 0, 1, 2. So these are the little slopes that we're going to put on the points that correspond to these. Okay, now I'm going to do it again. So this time, guys, all of the x squareds, 0 is x every time here. So all of the x squareds are going to be 0. And it actually doesn't even matter what y minus 1 is because 0 times anything is 0. So those are all zeros. So we're going to have little horizontal lines on all of those points. Now let's do this one. Oh, guys, again, x squared, x is +1 this time, but same as -1. When you square it, it's 1, 1, 1, 1, 1. And then I'm just plugging in these for that y, and yeah, you actually end up getting the same thing as like the first section. Okay, now it's time to plot the little slopes. Okay, Let me do the 0 ones first. Or actually, no, I'll do the 0 ones first. Okay, so all of these points that have the x-coordinate 0 also have slopes of 0. So here's all the ones that have x's of 0. So I'm just doing little horizontal lines there. But then guys, I've also got 0 slopes at -1, 1 and +1, 1. So yeah, we've also got 0 slopes there. So I put in my horizontal line slopes. Now, for the other slopes, I'll show you how I do it. So at -1, 0, I've got a slope of -1. So at -1, 0, I've got a slope of -1. So I'm just going to do some little dots. I'm going to go down 1, right 1, down 1, right 1. Okay, so that's how you do a slope of -1. You go down 1, right 1, or you go up 1, left 1. All right, so I just went down 1, right 1. And I'm going to go back and like connect those. I already did that. -1, 2, I've got a slope of 1. So I'm going to go up 1, right 1. Okay, so that'll help me draw that little slope. This one has a slope of 2. So I'm going to go up 2, right 1. Okay. Now, I'm actually kind of like repeating it. So -1 here. So down 1, right 1, 0, 1, up 1, right 1, 2, up 2, right 1. Okay, and then guys, I'm going to go back through and I'm just going to like connect them. So the little dot that I ended with, I'm just going to connect through the original dot. I ended with this little dot. I ended with this little dot. Yeah, and then if you do that, guys, you should get the relative steepness of the slopes like pretty accurate. Okay, so there's that. All right, we have got 2 more problems. Okay, so given the differential equation right here, find the particular solution y equals f of x with the initial condition f of 2 equals -3. Okay, so first let's look at the initial condition. What they're telling you here is that when x is 2, y is -3. All right, that's what they're telling you. All right, now I'm going to take this and I'm going to cross multiply. That ends up with x squared dy, x plus 5 dx. After you cross multiply, you make sure that these are all y's, these are all x's. You can't have x's and y's mixed at this point. Then you do the integral on both sides. Okay, antiderivative of this is 1/3 y cubed. Antiderivative of this is 1/2 x squared plus 5x plus c. Now you've got to find c. So you use the initial condition right here to find c. So I'm putting -3 in for y and 2 in for x. Let me save us time and look at my notes. And we end up getting -9 equals 12 plus c. All right, if you look at my notes, you'll see that I did more work. Okay, so there's that. So now that I know c, I know that with this initial condition, the particular solution is this. Okay, the general solution would be if you just left c, but the particular solution is when you find c. Now you've got to solve for y. So to get rid of this 1/3, I'm going to divide everything by 1/3. But dividing everything by 1/3 is the same as multiplying everything by 3 because of keep, change, flip. So this is y to the 3rd. 3/2 x squared plus 15x minus 63. Now, how do you get rid of a cubed? You get rid of something squared by square rooting. You get rid of something cubed by cube rooting. So y is the cubed root. Okay, and guys, I say this in the answer key. If you look at it, I write this down. You don't do plus or minus for a cubed root, okay? You don't need to do plus or minus when you take the cubed root. If it was the square root, you would need plus or minus. Okay. All right, guys. Now, my next class is actually about to start, and I still have one more problem. So let me pause this, and then I'll put up another video for that last problem. Or if I could figure out a way to, you know, cut and paste it, then I'll do that. Okay. Okay, so here is number 7. This is from K-18. Ooh, actually, this is K-19. I have to finish it. I have to fix this. K-19, and that's K-18. All right, so that was K-18. This is K-19. So what is the particular solution to the differential equation right here with the initial condition this? So let me translate the initial condition. They're telling us that when x equals 3, y equals -1. Now I'm going to take this, this differential equation and I'm going to cross multiply. So x squared dy equals 6y dx. And right away, guys, we've got a problem because we have to have just y's over here and just x's over there. So to get the x squared over here and to get the 6y over there, we've got to divide. So it actually ends up being 1 over 6y dy is 1 over x squared dx. Okay. Yeah. And then at this point, you've got to take the antiderivatives. Okay, and when I do that in the next line, I'm actually going to simplify these integrals just a little bit or rewrite them. I'm going to pull the 1/6 out front. And then I'm going to change 1 over x squared to x to the -2 so that I can actually take the antiderivative. So this is 1 over 6. Natural log absolute value of y is 1 over -1, x to the -1 plus c. Okay, and now at this point, I've got to find c. So I'm going to plug in the x's and y's. So 1/6 natural log, -1 plus c. Okay, so this is 1/6 natural log of +1, because that's absolute value, -1/3 plus c. Natural log of 1 is 0. All right, so that's actually 0. So we've got 0 equals -1/3 plus c. So c is 1/3. So our particular solution is this. Okay, but we've still got to solve for y. So I got to get rid of the 1/6. So I'm going to divide every term by it, which is the same as multiplying every term by 6. Okay. Then I've got to get rid of the natural log. So I put a base of e on both sides. That makes the natural log and the e cancel. All right. And so this is just absolute value of y is this. And then I need to drop the absolute values. And when you do that, you have to consider the positive case and the negative case. And then you have to figure out whether you're going to keep the positive case or the negative case. Whoops. And that's when you look at the initial condition again. Okay, so I'll say this. So since y of 3 equals -1, all right, so since y of 3 is a negative number, that means in order for this initial condition to work in here, we'd have to use the negative case. So y equals negative e to the negative 6x to the negative 1 plus 2. Okay, so that's the answer.